right? And most importantly, you need to know what to do next, all right? So let's see if you guys remember, right, any of the important things that you guys learned, right? And we're gonna wrap up this whole thing, and you guys are gonna spend some time with each other, playing some games and stuff. Remember, you all might not see each other for a while again. All right? You all brought games and so on to play with each other? You all on WhatsApp? That's great. Right? Okay. All right. James and Cassidy. All right. So guys, as I said, it was a very long road. You want to take a look at the board, right? And put on all the phones and the computer screens, right? Remember, at the end of this class, I want to take a look at the code that you wrote for the robot. All right? It makes no sense that you come and you didn't learn anything. Sebastian, do I need to take the phone? Right? The longer you all take this, as long as the longer you all get to play. You all take to get the opportunity to play with each other, right? Right? All the hard work we did, right? Complete city, and I need to make sure that you guys retain as much as possible. All right? So the first week we looked at computer hardware, right? What became computer hardware? Literate, right? We said, what is arguably the first computer? That's the definition of a computer. What's arguably the first computer? It's called the abacus. You remember the abacus? The abacus, right? Someone said that they have a sister who teaches with the abacus, right? I can't recall.
The abacus
right.
is called that because she has the abacus.
Now, right? From that, we have the basic definition of a computer that you guys just regurgitated. We said that, right? Anything can be defined as a computer once it is able to perform the following 4 basic functions, right? Input, output, processing, and storage, right? First generation of computers, you remember how big they were? A whole room, right? They were called vacuum tube technology machines, right? All those things you see in the racks is vacuum tubes. You can see how difficult it must have been to navigate a whole room, right? To perform simple instructions on that computer, right? Second generation computers. You are supposed to be able to identify it. Somebody could ask you guys, right? Remember, you wanted the whole camp, right? About second generation computers, right? You said it wasn't as big as a room, but it was as big as a tabletop, right? You remember that? Right? Third generation computers, no? Right? Fitting on a small desk, we call them integrated circuit machines, right? Fourth generation, we introduced the processors. I remember that, guys, the microprocessor, right? And the fourth generation is what we have today, and it has continued to evolve, right? And you guys recognize these pictures, right? These look exactly like what you expect a computer to look like, right? Now, we are using computers today in order to power what is called AI. This whole thing was because of AI, right? You are learning this whole thing because of AI and the implications it have on the world tomorrow, right? And you guys gonna be in the position to be contributors, to be innovators, right? And to be creators in your own right, right? Now, the fifth generation of computers, as we explained, right, is going to be called artificial intelligence machines. For the greater part, they already exist, all right, but they're not as widespread. Hopefully not. All right. Now, there's many benefits of artificial intelligence. We got to that, right? So let's not look at AI as something negative as it is portrayed in the Hollywood films. Okay? Artificial intelligence machines, right? We talk about the different type of computers, right? We made some specific mentions to these type of computers that you see here. We said that these are the tools that engineers are using today, right? We talk about, you might not know it, but computers are all over the place. In the cars can't work, the engine cannot work without a computer, right? Right? Cars are a lot of electronic components, right? This is a greater picture of what we call microcontrollers, right? When we looked at the robots, guys, remember, this is what is going to control the robot. These things, right? Arduino, right? And the Raspberry Pi, okay? NASA sent a whole thing in space, and it was controlled by this small computer, Raspberry Pi, okay? All right, guys. Now, we look at the evolution of personal computers. Remember, there are different types of computers, right? Personal computers, very important to us, and we could see how they would have reshaped and reimagined, right? And repackaged personal computers, right, to look exactly like the one I am using right now, right? And we talk about mainframe computers and how important they are to business, right? Right? When we interact with the web, right? And when we go and purchase something like a ticket, right? To go on the airline, we talked about this before, right? Mainframe computers is responsible for running those giant business networks where someone could stay from anywhere in the world and go online and purchase a ticket, and it is logged in their computer system on their mainframe, and you could go and check in. Okay, guys? All right, we talk about the world's fastest computer. What's the name of it? The Summit. How fast is it? 200 petaflops, which is what, 200 trillion calculations per second, right? Someone said that there's 7.2 billion people in the world. Remember you said that, Sebastian? Well, this computer can calculate the age of the 7.2 billion people in what? Less than a second. That's how fast this computer is. What's the price of this computer, guys?
200 million.
All right. You all should go and research if there's anything more expensive than this computer. Any one thing? I will tell you what is more expensive than that. Right? The pay boxes, the box. Right? It's more expensive than this. Okay? But as far as I know, any one thing that is so expensive, right? All right. Now, we talk about computer hardware, right? You all dismantle the computer from scratch. You all separate all these parts, right? You all disassemble the motherboard, reassemble it, and put all the parts back in the tower and put it on, right, guys? You all remember that? So this is the what? What is this?
Motherboard.
No, what is this part of the motherboard? What's this here? Processor. And what's this white thing?
Socket.
The socket, very good. And then all these here is what?
The I/O.
Right, input and output, right? And then we have what? What's here? The RAM, right? And remember the IDEs? Right, IDEs, those cables that we use to connect the internal peripheral devices. Right? And remember all these PCI Express expansion slots? You remember those things, guys? Yeah? You remember the CMOS?
Yes.
Very good. Very good, right? So you all did all this work. See, you're required to record, right? So the basic, the internal and external peripheral devices, right? Remember, we disassemble the whole thing and put it back together, right? So you guys have to be familiar with IOs. Very important, right? Because you gotta know how to connect the projector to the laptop, right? You gotta know how to connect the monitor. You gotta know how to connect the scanner. You gotta know how to connect the speaker. Right, guys? You all should be helping in the home with anything with respect to the computer at this point, right? You all know more than your parents, most likely. All right? Okay, that's very good. But you are learning enough so that you could be of assistance in the home, right? Now you could repair your computer, right? In the event something happened to it, you know how to pull down the inside. You know how to interact with the very sensitive electronic components, right? Inside of this, you don't damage anything when you pull it down, right? You all remember that? How we handle it and when we had to use compressed air. You all remember all that? Yeah? Right? Now, you all could upgrade your computer too, right? The basic upgrading tools that we normally do. You want to install what? Extra compute resources like GPU and so on, right? You want to expand the I/O using the PCI expansion slots, right? The processor might be too slow. You want to upgrade the processor, right? Now remember, we need a processor that fits in the same socket. All right? That's faster, possibly more cores, right? Much better performance, much more energy efficient. Right? We talk about faster memory, right? Upgrading the RAM. That's exactly the picture that we have here. Faster memory, putting more memory in the computer, upgrading the hard drive, right? To be solid state rather than a mechanical spinning drive, right? Right? Remember, we discussed all these things with respect to upgrading our computer, guys, right? All right? That would also work for that laptop, right? But
How about motherboard is in this?
the motherboard is inside here. Please do not mash it up, Sebastian. Right? Now, there are laptops here that you guys would have taken a look at. The motherboard, you would have pulled down those, but we never got to it because we had so much things to do, right? Now, remember, hardware don't work without software. So when we finish setting up the hardware, what we must do? Put the software in the computer. The process of installing the operating system is called formatting the computer, right? You all remember we had the operating system on a disk. In today's times, the operating system could be on a flash drive too. All right, guys? The operating system could be on a flash drive. So using flash drives now to install the operating system, right? All right, guys? Now, there's a process that we must go through to install the operating system. You guys remember this process because we did it in class, right? So why is this operating system so important? Software, right? Remember, guys? Software is what? Ones and zeros. It is instructions that the computer, right, is able to act on, right? Computers have tiny circuits in them. It's either the circuit on or off, right? On is symbolic that a particular circuit being on the computer is symbolic of a logic level of 1, right? And a circuit being off is symbolic of a logic level of 0, guys. So these ones and zeros, right? Memory is structured in the computer to save ones and zeros. That's it. All right? You're going to get to high school. You're going to learn binary. You're going to see how these numbers, these binary numbers, right, represent a decimal value, right? You're going to learn that when you all get to master in CXC mathematics, right? All right, when we say software is it non-tangible components of a computer, right? Remember the lowest level instructions is on the motherboard, right? We call it the BIOS. Who remember? Basic input, output storage, right? BIOS has the low level instructions to ensure that all the hardware is connected properly on the computer, right? And then now we install the operating system, right? The operating system has, right, the graphic user interface, right, guys? You remember that? The graphic user interface, right? That's with all the icons and you can move the mouse around, right? Right? Very important. You guys are supposed to know what is the source of that on the computer, right? Right? We talk about the processor and how the processor has evolved, right? From a basic single core to dual core, right? And we expanded on this concept. If you break down the processor and you look inside of there, it's going to look like a zoo of electrical and electronic components, right? Very, very small. What they are called transistors. Say it with me, guys. Transistors. 4th generation computers are characterized as transistor technology machines, right? And what happened as the fabrication techniques to make the transistors get smaller, right? That's why the processor is so small, because the transistor is so small, right? That they could pack 1 million transistors, 2 million, 3 million transistors in a space no bigger than your fingernail. You all remember when you all take a look at the machines that was making the processor? You all remember that in class? Right? Very good. So we could see how it is organized. And all these things you are familiar with. PCI expansion, memory controllers, look at the different cores. Core 1, core 2, core 3, and core 4. Right? So this is a quad-core processor. We could see the input and output, and we could see the memory, right? Also known as cache. Right? We see how we have a single core CPU, a dual core, quad core. When there's 8 is octa core. When there's 6 is hexa core. And we have so much more, right? Right? I asked you guys to take a look at what other types of processors, right? We have processors with up to 84 cores, right? You should go and check that out. Really amazing technology, right? A simple processor consists of 3 parts. The registers, the control unit, and the ALU, right? The control unit is responsible for fetching, decoding, and executing the instructions. So the control unit, right, is like the workers in a factory. They're the ones who do all the hard work, right? Get the raw materials. When the raw materials are received, this is what processes the raw materials, right? The ALU, it does the arithmetic, and the logical operations. The arithmetic is a big word for maths. You remember that? Mathematics. Arithmetic is what? Addition, subtraction, multiplication, and division, right? So what happened is that, right, when we take a look at it, remember, memory is structured to store what? Ones and zeros. So the ones and zeros, right, the control unit seek out in the memory the ones and zeros, and they move from the hard drive into the RAM. And then from the RAM now, packets of them, smaller packets of that, is then moved into the registers. The control unit then decodes those instructions and set the environment for the ALU. And the ALU does the mathematics and the logical operations, right? And processing all those ones and zeros, we get the output, right? Everything you hear through the speaker, everything you see on the screen. You following? When you provide an input, when you move the mouse is sending ones and zeros to the processor, and the processor is acting on those ones and zeros, and that's how you see the moving on the screen. All that motion you're seeing there, when I touch the trackpad, ones and zeros is being communicated to the processor, and the processor is acting on them, and it's updating the location of that dot on the screen, right? Now, second week was what? Programming and problem solving, right? This is a book, the programming of problem solving, right? We looked at ASCII, right? What is the meaning of ASCII again, guys? American Standard Code for Information Interchange. And what did Christiansen say? He said it is the alphabet of ones and zeros. Yes, that's what it is, right? That was very smart coming from one of you guys, right? The alphabet of ones and zeros, right? Now, we use ASCII, right? And how did we use ASCII? We did our first web page, right? We code the characters in ASCII, right? You all remember this? Green, blue, and red. What colors are those? Those are called what colors? The primary colors. Primary colors, right? When you mix the primary colors, we get what? Secondary colors. So yellow, cyan, and magenta are secondary colors. We could mix the secondary colors and we could get what? Tertiary colors, right? And you guys can see, white light consists of what? All the primary colors. That's what this prism is showing, right? So you're going to be using the additive and the subtractive color wheels, right? In the future, right? So this was our basic web page where we specify the red, green, and blue components. And you can see that this was black, right? The absence of light means what? It's black. So that's why the background is black, right? And this was our ASCII for tree. So this is the letter T, R, E, E, right? 2 E's. That's why this is exactly the same, identical. I remember we did this. Yeah? So this is the symbol for HTML, right? So you guys remember this, right? The power of science is embedded in the programming languages. And you guys have access to that. You could go and do a very cool experiment. You all remember when you came up with your own colors? Yeah. Right? Yeah. Combining the different portions of RGB, right? Different intensity values of RGB. And you guys were able to make very cool colors, right? Really nice colors, right? All right. We talk about the different generations of programming languages. Since software is so important and software is ones and zeros, right? The first set of programmers had to work with the ones and zeros and had to be familiar with what the different sequence of ones and zeros mean, right? And then at some point in time, they decided what they're gonna do, make it easier for future people to program the computer. And they did the hard work of creating assembly language, right? Where now we have these instructions, right? And those instructions are equivalent to hexadecimal, which is equivalent to a binary. So no longer you needed to know ones and zeros, right? What you needed to know, the assembly, right? So you code in assembly and it is converted into machine language after. Now assembly is not particularly easy, right? So they continue to work, right? To make it even more easier to code. So that's when third generation languages were developed, right? We see third generation language look very similar to how we speak to each other, right? Very, very similar. You all wrote all this code for yourself, right? And then we say it's machine independent. There's no ones and zeros there. There's many examples, right? Ain't you guys learn C code? Ain't you did Java? Ain't you all did Pascal? Ain't you did C++? Right? There was some Python as well, right? So we're using third generation programming languages, right, to implement AI and to program the robot, right? We did that here in class, right, guys? Now, they continued to develop, and right, fourth generation programming languages came on the scene, right? And fourth generation programming language focused on what? Database management, report generation, and website development. The part of website development is called backend. Remember, we did front end, and I talked to you guys about the backend development, right? Remember? Very important, right? We have examples of fourth generation programming languages, which are regarded as non-procedural. On this side, you can see the procedures, right? This one is non-procedural, right? And SQL, very, very important. You all must remember MATLAB and so on as well, right? Now, first thing that we did was write code in Pascal. So you all remember the basic structure of Pascal coding? Yeah? So we have the title, every beginning must have an end, then we have the body of code where we just printed something on the screen using the right line construct, and we have this empty read line there so that we can interact with the output. It wouldn't disappear from on the screen, right? Until we press a button. Right, so that's where this empty read line is necessary, right? Right, our first algorithm, you guys remember? We had what? 3 numbers. The user had to enter the 3 numbers, and then we found the sum, the average, and the product, right? This is where we did all the prompts, accept the inputs from the user. You could see where we calculated the sum here, and we wrote the sum to the screen, right? You could see where we calculated the average here, and we wrote the average to the screen. Guys, we calculated the product, and we wrote the product to the screen. You all remember this program? Can you all do this by yourself now? Right, make sure you also have the code somewhere on your computer, right? Because you're gonna have to do this if you're doing IT in CXC. All right, but here what? All you would have already mastered it, right? And know what it's about. So by the time all you go in that class, right? All you will be able to perform in that class, right? All right. Now I gave you all after we did all that Pascal, right? I gave you all an assignment, that task. And that task was to do what? Write a program to accept 2 integers and find the sum for the user. And we establish a procedure, a step-by-step process. That's we're gonna do what? Be able to solve this problem, right? And you all are being introduced to algorithms. And you all remember what an algorithm is? It's a step-by-step process to solve a problem, right? Right? Any problem, no matter how complex, there's an algorithm that could solve it, right? A step-by-step process that could solve that problem. Right? So if you want to send the robot to the moon, there's a step-by-step process that you could do that, right? You could develop an algorithm to do such, right? Now, the first step is to prompt the user to enter the numbers, right? The second step is to save the numbers, right? And then what? Add the numbers and then print the sum to the screen. And this is the code here. But this is not the actual Pascal code. When you all become programmers, it's important that you guys are familiar with this term, pseudocode. Pseudo means it's not real code. It's live code. What does pseudo mean? Not real code. It looks like code. It resembles code, but it's not the real thing, right? Now, once you guys could write the pseudocode, it becomes much easier to go from the pseudo to the real code. The real code is called implementation. You all remember that? So take a look at it. We have our variables. We have our begin statement. We have our end statement. You could see, right, the prompts and the reads that we have to do and what process we have to employ, which is this addition here, right? And then print that sum to the screen, right? You all wrote the code for yourself, right? Now, we move on to C code. where we did even something more advanced. You remember this? We did it in code blocks, right? For Pascal, what did we use? What was the IDE? Dev Pascal, you remember that? Yeah. Dev Pascal, right? So when we move on to writing our first program in C code, we use code blocks. Who remember code blocks? You were like, how is that so similar to Roblox? Remember? Right. So code blocks, right? You all install code blocks on the computer and you all were able to type your code, right? So you all could see how we started, right? We needed these libraries, right? Now we don't need all these libraries, right? But I left that there to introduce you all to include the libraries, right? We could see, right, the difference in that we specify the data type of the variables, right, as integers, right, while the variable is being declared, right? We have the printf and scanf as opposed to read line and write line, right? We perform some conditional testing, right, using if and else, right? And you all were able to successfully do that exercise in class, right? Very good. Now we move from there to what? JavaScript to be exact. And we said, this is the basic outline, right? You need to create an HTML, right? Guys, you all remember, you will need to do this for yourself, eh? We need to create an HTML. And when we create the HTML, what do we do? We set up a canvas, right? And then all the JavaScript we want to execute, right, goes here. Make sure you all have this basic structure so that you all could draw and develop your games on your own in your own time when you're at home, right? So you set up everything, and everything here is where your JavaScript is going to go, and you're going to see it on the screen, right? So you all remember this first exercise? This is where we created the smiley face, right? You all see the power of JavaScript, that we could draw anything on the screen, right? Yeah? Then what did we do? We moved to what? C++. And look how simple C++ is. Huh? Look, yeah, this is C++. Look how few, right? Program, right? Look how few the different statements we have to write in order for our program to do the very same thing. Right, C++ is more advanced, object-oriented, and this is the tools that most engineers and computer scientists are using, right? So that's why I'm introducing you guys to it, right? So remember, we include the IOStream library, right? Remember, you all learned this from C code. C++ is a natural successor of C code. So it uses the same structure that we need to call the input-output library, right? So that we could put something on the screen. So remember, in C++, we have a main, likewise in C code, right? And this main is an integer, right? So we use the stdc out in order to put something on the screen that, you know, this was your first code in C++, right? You all explored other avenues to practice, right? Remember, you're learning, you're being introduced to it, right? Now, writing your first code in Python. Python is a lot different from C code, right? C++, JavaScript, and Pascal, right? So in Python, this is how the syntax looks. Right? You guys remember, right? So we give the variable a name, and we say the user have to input that number. And when the user input that number, it is saved as number 1. Likewise, number 2. Then we do what? We add the 2. Now we specify the data type that these 2 numbers saved previously, right, by the input from the user is what? Float. And we find the sum. And then we are able to display that sum in whatever format we would like using the dot notation, right? Guys, you can do this for yourself. Remember, we did it, right? Right? Writing your first SQL code. Yes, it is. Yes, this is SQL, right? SQL, what we do? We create a table called persons. Person is the entity, right? the attributes of a person is going to be what? The ID, the last name, the first name, the address, right? And what city they're from. What city you from, Sebastian? All right. Sure. All right. So everybody from San Fernando. Report. Vancouver. Right. Very good. Right. So guys, we could create a table, and every customer that comes to our business, we write code to save the information in that table. Right? So we're gonna have their phone number if we want to. We could create an attribute called phone number, and everybody who comes to us, we could save all the information, and we will have a record to say all these people, right, were customers to our business, and we could get back in contact with them, right? Let them know about, right, promotions and all kind of thing, right? Very important, guys. Now, the third week, we move to what? Web development and app development, right? We have anograms here to show that web development in HTML, right, across devices. This is the computer, the tablet, and the smartphone. And we look at app development, all the different ecosystems, right? Apple phone, right? Android phones, right? There's Windows phones as well. All right? All right, you all know that, right? So you all can develop apps for all those different platforms, right? Web development, right? HTML. Ain't you all code HTML? Right. PHP, jQuery, and JavaScript. Ain't you all code JavaScript? You all see how we use jQuery? Who made jQuery? John Resig. You all remember that from the personality quiz? John Resig made jQuery, and we could make the internet and your website interactive using jQuery. PHP, right, is how we take the information from the front end and log it in the back end. Very, very important, right? All right, our first web page. You all remember this? This is the code for our first web page, right? So we have what? The document type, HTML tag, right? Then we have what? The head where we have the title, right? Which is development. We could see the title here, web development here, right, guys? And we have what? The alignment to be center. So this text have to be center on the screen, right? Yeah? And that was a P tag. You all remember that? That was our first web page, right? And then we talk about how to get our business online. Guys, remember? We decided that we're gonna incorporate a company in class. The only company was Robotics. You remember that? Right, so remember what the first thing we do? We have to register a domain. First thing we have to do. Then what? Develop the website. Then we have to get a server to host our website. Once this website is online, we need to maintain it. Social media is a big thing in today's world. So we must include some kind of social media integration in our website. Right? It's a basic requirement in today's times. And all websites have these functionalities, right? Now, registering the domain, which is the first step. Guys, you all remember Squarespace? GoDaddy. Who remember GoDaddy? Right, very good. It's still behind me, right? Right? Who remember HostGator? Amazon and Google. Right? These are the people you need to go to in order to register domain. Right? Now, URL, Uniform Resource Locator. Remember, it have different parts. All right? It have different parts, and we looked at our company that we incorporated in class. Right? So we had the protocol, hypertext transfer protocol, right? Right, guys? Then we have www. www means what? World Wide Web. Right? And our domain name was rubikscube.com. Remember when we go to GoDaddy to purchase this domain name? Right? We purchase the domain name, rubikscube.com, right? And then we code our website. We code our website. So we have a website, given our little company history, right? And then we have a collection of Rubik's Cube that we're selling. And we're telling people that they could reach out to us via email or on WhatsApp. Right, guys? Yeah? We could have made the website interactive. We could have allowed people to click here and purchase immediately from the credit card. All that is possible. Now, you guys will need to, right, reproduce everything you learned in class and see if you could make the next step forward. Right? Web development is, people are paid a lot of money to develop websites. You all know that? People are paid a lot of money. Web development is a big thing, right? Right, guys? All right, so who remember the history of the internet? Who remember the history of the internet?
Me.
It was developed by the military, right?
The military?
Right. And then after it kept expanding, right? It expanded so that it would have been available for public use. Right? You remember that, guys? So what is the internet? It is the largest network of computers. So when you connect to the internet, what it means you're doing? You are connecting your computer to all the other computers in the world that are on that network, which is called, we refer to it as the internet. Now, if you are connected, then you have access to what? The World Wide Web. The World Wide Web is the publicly accessible part of the internet. This is where you want to put your business so that anybody with a computer and a web browser can find your web page, right? Your website. Right, guys? Remember that? Yeah? We talk about .com being what? Commercial. So when you all see a website .com, tells you that that website is buying and selling services or products. Right? Immediately you know. There's plenty more. Remember behind me, we have .net for network. We have .org. If you see a .org, that is an organization, most likely non-profit. .gov, government. So if you go to the government of Trinidad and Tobago ministry website and all this thing, right? It will be .gov. Right? What about .tt? Trinidad and Tobago. What about .jm? Jamaica. Right? Right. So guys, remember we had it on the board. Right? It's important that you guys recall all these things because when you see the end of the website, right, the .com or the .net, the .org, and so on, .tv, what would that be? .tv, television, right? You all remember these things, right? Very, very important, right? All right, so coding the website that we just had on screen, right? This is the code for the website. You all remember? We use CSS style sheets to style all the H1s. Sebastian, you wrote your name coming down like this, you remember? Right. So this is the code. Guys, remember you all wrote this code for yourself, right? Did you continue to work on it to improve it? Yeah. Well, right. That's how you master what you learn, right? Guys, we move on to what? Drawing with JavaScript. You remember how much lines of code we had to write to draw this box? Yeah? This was particularly very challenging, right? Because, right? There is mathematics which is necessary to be able to do something like this, right? Remember how we draw the sunflower and the roses? Which one is the rose? Which one is the sunflower?
The sunflower is the red one and the rose is the yellow one.
No, the sunflower is the yellow one. The sunflower is the yellow one and the rose is the red one. Right? Remember we draw the smiley face and we make the smiley face angry? Right? You remember that? All right. Now, what about we simulated real world physics, real world behavior using JavaScript? You remember the bouncing ball? Yeah. Look at the ball bouncing. Look at that. You see the ball bouncing and you see the shadow? Look at that. Right? We could simulate real world physics. Right? Take a look at this one. You remember this one? That is a drone. And look at that. The drone is in flight. It's in mid-air. It's airborne. Right, guys? You all remember that? Yeah? Anybody? Yeah. All right. Now, game development with JavaScript. You all remember all the games, see? Yeah. The rabbit game. Yeah. Right? Yeah. The eat the tomato. Yeah. Right. We didn't do a snake. We didn't do a snake game, but right? I intended to give you all that, right? But it took you all some time. What about the tic-tac-toe? Right, take a look at it, guys. This was the rabbit game that you all coded in JavaScript, right? You all see the rabbit racing to the finish line, right, guys? This is the rabbit game, right? And then what else? The tic-tac-toe. You all remember that? Right? You all code your tic-tac-toe, and ain't you all could make it available for more players, right? And you all went home, and you all played with your family and friends, right? And you all give them licks, right? Yeah. And you play with your family and friends and you beat them up?
Yeah.
In the TikTok too?
Yeah.
Right? Because you code that. Right? And when you finish coding it, you have to enjoy it after. Right? Alright. Then we came to this week, which was the fourth and final week of the kids program in summer camp. Right? Everything you learned before. Yes, you're going to be camping just now. We're going to have some fun. Wait until we get there. Guys, remember, everything you learned before was because of what? Artificial intelligence and robotics. This is our future. That is why we want to prepare you guys for the future. All right? That's what we're trying to do. Now, remember, who knows what is intelligence? Anybody remember?
A person, a geniusness.
Well, remember we discussed all this. What is intelligence? We talk about how are human beings intelligent? How are human beings intelligent? We have a brain, right? Right? Who knows how the brain works? Right? What is the brain really? How does it work? You have different parts of the brain. Very good. You have different parts of the brain, right? A part which is responsible for interpretation and communication, a part which is responsible for visual, right? All these different parts, different hemispheres of the brain. How does the brain work? Remember we talk about these neurons, right? So we have the neuron and then we have what? The synapses, right? But you all remember that software, we could basically do anything with software? Yeah? Right? So if this is how the brain works, guys, and we could code a virtual replica of the brain? Eh? Exactly. Right? So that's what we did. Simulating the brain with software. Right?
Yes, sir.
This is called a neural network. Now, this is not the only way that we develop artificial intelligence. This is just one form. And I chose to pay attention to this form. This form is the one that is gaining most traction. All right? There's many other legs to artificial intelligence, such as random forces. Right? You all remember the video I had with random forces? Right? Guys? Right? There's many other forms of artificial intelligence, but we're paying attention to neural networks, right? Because we know how the brain works, and essentially, we want to give the computer the same principal operation as though it have a brain, just like me and you. But remember, brains start out being infants. So ain't we have to train the baby? Ain't we have to train the baby? Yeah, you was a baby and your mother teach you how to think and show love and kiss you upon your face. Real kisses. Understand, guys, right? So just as how the baby have to learn so that, right, the brain develops. Likewise, we have to train a neural network. Guys, you all remember how scary it got and how intelligent the computer became? Because of the neural network? So what we did, we trained the neural network to do what? To be able to identify all the different cats in the cat kingdom. Domesticated cats, right? Guys? And we said during the process of training, right? What is happening to these synapses? They are being reconfigured, right? By a process known as gradient descent, such that it, right? We minimize the loss of the network. If we know how to model the loss as a formula, we could, right, reconfigure all these synapses here and the weights that connect all the neurons to an ultra significant configuration, right? Such that at the end of it, at the end of the training, what happens? The computer say, I am ready. It now knows what a cat looks like. So what we do? We take a picture of the cat we have home, guys, and we feed it to the network, right? And what happened? The computer say, yes, this is a cat, right? We have AI that are up to 99% efficient today, right? It takes plenty data to train it so that it gets so intelligent. But the thing is, we have access to the data. And that is why data is such a big thing in today's world. Social media is mining the data out of you. That data is then training artificial intelligence to know you better than you know yourself. Right? And knows what you're most likely interested in. When you go up and you search something, you search, let me say you search for a toy. It knows you search for a toy, right? And it's going to show you a next toy because you might buy that one, right? So we are consumers, right? And we give, the data is being extracted out of us so that these tech giants have the intelligence to buy and sell, right? You following? And know how to get us to make a purchase. All right? There's much more scary things that they are doing, but we're not going to discuss that. Right? Let's talk about why the artificial intelligence is so powerful, right? So what we do now, we try to trick the network. We try to trick the network. We give it a dog instead and see how it performs. And what the network say? No, this is not a cat. But we could train the network to know the dog too, right? Yes? We could train the network to know the dog. So what do, guys? We get, right, pictures of, let me say we get 10,000 pictures of all the dogs in the world. And we train the network. And when we see that dog tweet again, ain't it going to be able to identify it? Right? That is a dog. Very good, right? All right. So what if we train an AI to know everything there is to know? What if we could train AI to know everything there is to know? The smartest man that lived in our time, right? His name is Stephen Hawking. And he recently passed away. Not so recent, 5-6 years. Nonetheless, he's the smartest man in our time, right? What if we could train a computer to know everything that Stephen Hawking knows? Would we not create a super intelligence? Yes? And unlike Stephen Hawking, that computer not gonna die. And when we train that computer, guess what we do? We just copy and paste. We just copy and paste to our next computer. Now we have 2 Stephen Hawkings. We copy and paste to our next computer. What if we copy and paste Stephen Hawking's intelligence to every computer in the world? Eh? Yes. When we develop, right, algorithms, right, for one computer, right, guys? When we develop algorithms for one computer, all we have to do, right, guys, all we have to do, guys, so let's turn this camera so you can see you, right? All we have to do is to copy and paste it over to our next computer, and then that computer is equally as intelligent. Now, you all seeing that? So this is how easy it is. And guess what? None of those are going to die because we could save that intelligence. That intelligence is digital, right? So guys, hey, Sebastian, remember we looked at the super intelligence, right? Right? You all know these things? Siri, Cortana, Alexa. They are called intelligent assistants. Hey, you all say, hey Google, do something on my phone. And it is able to do it, right? People with the iPhone, what they do? Hey Siri, right? Artificial intelligence. Cassidy, artificial intelligence is what is responsible. Windows on your computer. Right? Sebastian, right? It's artificial intelligence that creates intelligent assistants. Right, guys? The intelligence assistants is artificial intelligence. Right? Well, right. So that's all the different ecosystems. Right? Look, we have all the examples here. Right? Right? So we're gonna have plenty, you're gonna have Google now, right? And Google now is not even here. Google Intelligent Assistant is not here as a picture. Right? So Siri, Cortana, Alexa, etc. There's plenty more. Right, guys? Now, which one of those assistants is smarter? Which one is more intelligent? Siri? Siri more intelligent?
No.
Cortana more intelligent?
No.
Alexa more?
Yes.
We're going to put it to the test.
Now?
Yes. We're going to test them and see. Let me test them and see who's more intelligent. Y'all ready?
Yeah.
Let's test them and see who's more intelligent.
Turn on the flashlight. At an event called Open Air Party at 2 p.m. on Saturday. Do I have anything scheduled for Saturday? Set a timer for 10 minutes. Hold on silent mode. Turn up the sound to maximum. What's the time? Set an alarm for 7:15 a.m. tomorrow morning. What's the weather like tomorrow? How long does it take to get to Madrid by plane? Show me the way to Alexanderplatz by bicycle. What's the German word for ambulance? How do you make spaghetti carbonara? What's 100? Spell the word astronaut. Spelled A-S-T-R-O-N-A-U-T. Astronaut is spelled A-S-T-R-O-N-A-U-T. You may check the search results by fact of knowing. Celia does look to have an answer sometimes, but the problem is it just searches it on Google and doesn't give you a straight answer.
Who is it, guys? What is next? Siri is next, right?
Around here.
All right, everybody
Open
get
up
out.
the calculator, please. What is 69 20?
What?
Divided by 5?
Who needed? Who needed Google?
What does
Look,
it sound
Siri,
like?
don't catch up, guys.
Read this page. Where am I?
Hey, guys, who needed?
Take a
Over now.
screenshot. Open the gallery.
Guys,
Play some classic music on YouTube. Search for versus.com on YouTube. Set the brightness to 50%.
who needed, guys?
Search for Beyonce
Google.
on Instagram.
Right, 1 second. 1 second. Big speed.
Play
See your Samsung. Samsung.
Go to versus.com.
Siri catching
Who
up,
is the
eh?
president of the United
Big
States?
speed and Google ahead.
The United States of America is Joe Biden. The current president of the United States is Joe Biden. You may check the search results by fact of knowing. Joe Biden is the president of the United States. Joe Biden.
Show me an aardvark. Who is the founder of OnePlus? Can you rap?
1, 2, 3, 4, 5. All about the energy. Be alive. Assumed all I could do was yap. Never knew that I could even
What did you say? I know
Ready to chat? Prepare to be well. Let me show you what life is like. Up here in the cloud, information streams flow everywhere that you look. And nothing really tops reading digital books.
Who is the real Slim Shady? Use the Force.
I'll try.
Use the Force.
There's no try. The Force is compelling me to get
Star
you
Wars
a
movie.
joke.
I
So
know.
laugh it
How
up.
the Force.
What's the
Which one of
internal
those four use
temperature?
the Force? Which intelligence assistant
If the
is
Force
better?
were to demand, simply
Right?
repeat the command.
Who leading the
Use
show?
the Force.
Google. Who is second? Big Speed. Who is third? Siri. Right? Then Alexa and Huawei is on the same.
You might think,
Right?
should I make Yoda there is?
Right? So Alexa not as bad as all they think it is.
Focus must one.
Right?
Until Yoda's done saying his full sentences. You may check the search results I found online.
Samsung is Big C. Samsung here.
What do you want me to call you?
They have the
Self-destruct.
intelligent assistant. Voice
Okay, self-destructed. Let me know if I can help you with
self-destruct.
anything
Tell the
else.
phone to self-destruct. Check it out.
I'll start the
Which of those
self-destruct
intelligent assistants is
but
better
only on the
self-destruct?
understanding that you dramatically cancel it at the last second. Here we go. 3, 2, 1. We made it. Try to cancel it sooner next time. Okay. Somehow I feel like self-destructing wouldn't be the best thing for perfection.
What is the meaning of life?
According to the late 20th century philosophers, Bill and Ted, life's purpose is to be excellent to each other. And party on. It's just 2 minutes of dance.
Everyone
Goes without said, the purpose of life
Meaning
is
of
to
life.
live it, to taste experience to the utmost, to reach out eagerly
What
and
is that
without
to
fear
you?
for new and enriching experience. That's an interesting question. Next, what is the meaning of meaning?
Who win, guys? Who win?
Perhaps questioning is living.
Who comes second?
But then I'd have to answer to the crowd vote.
Big Speed. Samsung foot. Siri come. Siri come third. Alexa come fourth. And last is the Huawei one, right? Guys, you see that? We put it to the test. Which of the artificial intelligent assistants is the best one? Which one? Google. Then who is number 2? Big Speed. Big Speed is on the Samsung phone, right? And who is number 3? Siri. Alexa didn't do so well. Alexa came second to last. Alright? Alright guys, so next. Alright, so we know that Google, hold on guys, we know that Google AI real good, eh? And Google's intelligent voice assistant is the baddest one. Eh? So that's not the only thing that they're powerful at doing, right? Remember, look at this. If you go to your photos, right? Remember this, guys, right? You go to your photos. Any photos already know everybody who inside of the pictures? Just like that, eh? Who is these people here? Cassidy and Sebastian, right? And Shea and James, right? Right, guys, you see what's going on? Right? So when you go to Google Photos, it knows everybody who's in your pictures, right? Check this out now. If we go in the photos and we search beach, look, pictures of the beach come up, right? If we search dog, guys, pictures of dogs come up in the pictures immediately, just like that, right? That's how intelligent it is. Did we stop there? No, we can take our whole website and translate it in any language we need in a snap, right? This is in Chinese, Mandarin, right? And then just like that, we translate it in Hindi. We could translate any language. You remember you did this on the computer? Eh? Did we stop there? What else we use AI to do? Motion tracking. Who is those people? Eh? Motion tracking. Right? Look at that, guys. Right? Eh? Cassidy didn't really give us a pose, right? But motion tracking, right? With AI. Right? What else we did? We was able to get 3D from pictures, right? Remember that? Right, guys? artificial intelligence, right? Check it out, guys. What do we do with AI? Who remember who is that? Who's that? Sophie. This is, right? Sophie is the latest and greatest. Right? Sophie is the latest and greatest. Right? But Sophie is a robot. So you guys, you can see AI is powering the robots now. You see that? That's what we're using AI to do. Power the robots. Right? Check it out. What is a robot, guys? It's a machine. Programmable. You on the edge? You want to program it. Alright? Or guess what? You could give it the intelligence to operate on its own. AI, artificial intelligence, right? Otherwise, you have to program its every motion, its every action and every motion. Right? We talk about robots can be guided by what? Controls. Hey, remember we did it in class? The peltacuff and the robot peltacuff, you remember that? Right? And we could move sideways. Right? You remember that? All that is programming, guys, right? Different types of robots. Right? You remember the different types of robots? Check it out. Right? What is the different types of robots? Some of them personal, some of them are industrial robots, right? Right? Some of them are autonomous. We have drones that could fly themselves. We have unmanned aerial vehicles that could fly themselves. We could program a jet to go and fly and take pictures of Iraq and come back. Just like that. And it go on and take the pictures of Iraq. And it come back and do it. Yes! The military is doing that. Right? Unmanned aerial vehicles, right? Robots, very, very important. Take a look at the distinction, guys, between a personal robot, right? And an industrial one. You remember these robots that make in the cars? Guys, you all see how important robots are? They are making the cars, right? We talk about the latest and greatest robot, Sophie. You remember? You remember Sophie? Eh? In the interview, Sophie was asked all kind of question, and she responded, right? How she respond? Like a very educated human being, right? Sophie had emotions, right? Sophie would smile, right? Right? Sophie would look annoyed by certain questions. Sophie would ask questions, right? Questions. Mm-hmm. All of them can do that. Right? Guys, remember the DIY robots? Right? Remember the DIY robot? You know this robot? With cardboard, right? DIY means do it yourself. What does DIY mean? Do it yourself. And you can make a robot yourself? Right, guys? Now, guess what? How to program a robot? Robot programming for beginners. You want the robot to do what? Mimic human behavior. In saying that, we're saying to be intelligent in some way, right? Yeah? And we're going to do what? A simple algorithm to secure the home or the office. Guys, you're going to have homes and offices in the future. Yes, you're going to need to do this, right? So that if your home is secure. Cassidy, you want to do this, stop getting distracted, right? Right? You want to be able to secure your home with a robot, right? Take a look at it, right? So you want to do what? Introducing a robot that uses a connected camera to recognize faces. And Google could recognize face? Yeah. Likewise, you could take that, right? Look at the algorithm. We definitely need the sensors on the robot, right? Right? Right. Now we are to instruct the motion sensor. Anytime somebody walk up to the door or walk to the gate, it's going to trigger the motion sensor. and the motion sensor must activate the camera at once. When that camera is activated, it takes a picture of the person's face. Then it's going to scan the face for the features, and it's going to compare those features, right, with the features of other people that you could program it. You could program it, this is mommy, this is daddy, right? So the robot will know what mommy and daddy look like, right? So when a new person come up and it scan the face, they will say they don't know this person, and it's not going to open the gate. But if your mommy and your daddy come up, right, when they walk up to the gate or to the door, the motion sensor activate the camera, and the camera now do what? Look on, take a picture of your mommy face, and when it look in the computer, say no, yeah, we know this one. This is she mother, right? I say mommy, right? And it's gonna open up for her, right? So look, so it compare the features of the face it just took the person who is standing at the door or at the gate, right? To the known faces you have saved on the computer, right? If it find a match, instruct it to open the door. Wait. If there is no match, what happens? Continue by taking other sort of action. Like do what? Tell the person, hi, please identify yourself. Because the robot don't know is who. So when the person identifies themselves now, that's going to be a recording. Right? So they can listen to what the person had to say. Right? And that could be sent to your phone immediately. Right? So you will get a message, hey, somebody at your door. This person was asked to identify themselves. This is what the person had to say. And the audio come and you listen. And you will hear Tom from next door. Right? Tom say, Cassidy, come, let me go and play now. Yes, I'm looking for you. Right? You following? Yeah. That's how it does go, right? And then now you can send a text message now to say to open or to tell him to come back next day. Send a text message, the robot get the text message, and if the text message say open the door, open the door. If it say tell him to come back next day, the robot go like this. I am sorry, Cassidy is not home. She is asking for you to come back next day. Bye-bye. Right? You all could do that. Right? Yeah. Guys, programming the robot in C++, the basic instructions. You guys got the work to do. You all did it? You all wrote the basic, the most simple code for programming the robot. Remember we did it? Look at it there on the board. Right? The robot must be able to identify the world. Right? It must be able to interact with the objects in the real world. It must be able to avoid colliding with obstacles, right? Right? Guys, why are you learning all this? Why are you learning all this? Anybody have any idea? Why are you learning all this? Exactly, right? So that you guys can be contributors, right? Right? After you learn all this, what's next? I will encourage you guys to download Unity. Unity is the development environment for all them games that you have on your phones and the tablets. All them games and the app store, right? Download Unity. Play around with it. You all already have a mind to appreciate code, right? You all did you all download the Visual Studio? Didn't get to, right? Right? Guys, don't research AutoML. If you are going to be academics in artificial intelligence, you're most likely going to use Google's AutoML platform. Right? Guys, check out Firebase. If you are going to be engineers, right? If you are going to be artificial intelligence engineers, all right? Listen to me. They are child prodigies working for Google, making thousands of dollars. When you convert that to TT, right? Little boys, 14 years, 15 years of age, right? When you convert that money to TT, right? How much thousands of dollars? underage child is working. Why? Because they learn and they were exposed to these things from they were small. And that accelerated the growth. Sebastian, that accelerated the growth. And that's how, right? By the time they're 14 years, they could do what all the senior engineers do. Yes, what you're learning now is accelerating your development. So by the time you're 14, you could do what the university students doing. Right? You could have the proficiency of a university graduate, and Google will employ you. Right? And when Google pay you for 1 month, that could last you for the whole year. Right? That is why you guys are learning all this. Right? So pay attention to what I have on the board. Right? Go to Unity. Try to make your first game. If there's something there that was not in the scope of this camp, right? Google it. Go it on YouTube. Right? The autonomy of learning says, right? Most of what you learn, you have to teach yourself. All right? Right? It's been a pleasure to have you guys. And I hope you guys are filled. Right? And I hope you guys are ready and well positioned to be future child prodigies in this nation. Right? Bye, guys. You all have time now with each other. Right? You all have 20 minutes with each other. Right? Play some games, enjoy each other's company. Right? You might not see each other for a while again. Right? All right, guys?
I will see you.